The next one is losses of prestress. The first loss, what is losses of prestress? If we are applying a prestressing force on a beam, there is prestressing force P. It may be 1200 Newton per mm square, but after providing this one, it may reduces to slightly. It may reduces maybe 1%, maybe 10% as like. Maybe it's reducing. That is called losses of prestress. So it's having some several types. The types as the first one as elastic deformation due to elastic deformation. What is elastic deformation? If we are providing a rod, instead of rod, we are providing high tensile wire. High tensile wire we are providing. After providing, if we are using a high elastic wire, it elastically deforms. It gets a small amount of elastic deformation gets due to its this is concrete and this is the wire is steel. So both having the different elastic modulus, that is E. There is if we steel having ES and concrete having EC. So it's having different elastic modulus, so it's having the shrinkage values also is different. So due to this elastic differences, elastic modulus differences is having a shrinkage. That will leads to a loss of prestress. That we can calculate by alpha E is equal to ES by EC. That is ES is steel modulus velocity of steel. This is modulus velocity of concrete. Then second case is losses due to the shrinkage of concrete. Due to shrinkage. Due to shrinkage, the concrete should shrink when it is loaded or after 28 days of curing. And that is in pre-tensioning, the shrinkage value should be 300 into 10 power 6 when it is pre-tension. We already discussed what is pre-tensioning. Then in the case of post-tensioning, the value should have 200 into 10 power minus 6 log out of 10 t plus t is the time or age of concrete in days. T in days, that is 28 days as like. This is for post tension. This is for post tension. So we have two equations due to the in case of shrinkage. The most of the case we are not using this equation. The question itself we are given the values. Question itself we are given the value should be given. So we're not bothering about these things in the question. But in the case of when the question paper will ask that loss of prestress, it will help you. Then third one. This is due to the creep of concrete. Creep of concrete. It will be calculated by epsilon Cc Fc Es. This is ultimate concrete strain. Creep strain. Ultimate creep strain. Fc is the stress value. Es is the modulus of elasticity of steel. Okay, right now you can see this. There is epsilon Cc into Fc. Es is the modulus velocity of steel. Fc is the creep strain. Stress value, and the epsilon Cc is the ultimate creep strain. Okay. So it's having actually two methods. That is first one ultimate creep strain method, and second one coefficient creep coefficient method. As you like, which we can discuss these things in problems, but it should be better. The next thing is losses due to relaxation. Losses due to relaxation. What is relaxation? If you have provided a force on a spring, if it is this is a spring, if you are providing a force on a spring, it will extend as like this. So it may be, if it is L1, the length should be L2. So after this is P, this is P, this is P, this is P. Okay. After a continuous application of this P over here, this L2 will be, after continuous applying of law for long time, after a long time, if we are release this P, it will not regain to L2 to L1. It will not goes to that. So instead of L1, it may be something different. L1 plus X as like small change it will be there. That is called relaxation. It may be in percentage. It may be 5%, 4% as like. It is only purely depend about the material constant, material property. So which type of material we are using, which type of steel we are using, according to that this relaxation percentage may change. So it's purely depend about the material, so it will given to your question paper. So otherwise you can't calculate this one because it's only calculated by your experimental works. The next thing is, next law is due to successive tensioning. Due to successive tension. What is successive tension? If you are provided, this is a beam, we are providing this one. If you are, this is a hole over there, this is post tensioning. This in the case of post tensioning, this is only in post tensioning. It will be possible in post tensioning only. We are providing one wire over through, and then we are providing a P over there, so it's tightened. Then it will go, next wire will provide it here, and it's also tightened. The next wire it will be goes there, and next this will be tightened. After few numbers of the first one may be some ways loose, some ways its tension may be lost. There is successive tensioning, continuous tensioning of continuous wires. The first one may be relax. That is called successive tensioning. Due to successive tensioning, it may happen. So we should identify the value by experimental method, and then we are providing an extra percentage for these type of losses.